Hello students, I am Dr. R. Krishnakumari, Assistant Professor, Department of Mathematics, Faculty of Engineering and Technology, SRM Institute of Science and Technology, Katangulathur, Tamil Nadu. Today we are going to see about theoretical distributions. So today we are going to see about two types of distributions, discrete type and continuous type. In discrete type, we are going to see about binomial distribution, Poisson and geometric distribution. In continuous type, we are going to see about rectangular distribution, exponential and normal distribution. Binomial distribution. A random variable x is said to follow binomial distribution if it assumes only non-negative values and its probability mass function is given by P of x is equal to x is equal to ncx px q n minus x, where x varies from 0 to n. The parameters p and q follow a relation such that q is equal to 1 minus p. Now let us see a sum based on binomial distribution. 6 dice are thrown 729 times. How many times do you expect at least 3 dice show 5 or 6? So let the number of times the dice show 5 or 6 is going to be 1 by 6 plus 1 by 6, so which is going to be 1 by 3. So this shows that the parameter p that follows the probability of success is going to be 1 by 3, and q that follows the probability of failures is going to be 2 by 3. And the total number is denoted by n, which is going to be equal to 6. Therefore, by binomial theorem, p of x is greater than or equal to 3 is going to be probability of 3, probability of getting 4 plus probability of getting 5 plus probability of getting 6. So the answer for this after using the binomial distribution formula is going to be 0.3196. So they have mentioned that 6 dice are thrown 729 times. Therefore, the expected number of times at least 3 dice to show 5 or 6 is going to be the capital N, which denotes the number of times into the probability greater than or equal to 3. So this is going to be equal to 729 into 0.3196, which is going to be 233 times. Next, we are going to see about Poisson distribution. A random variable x is said to follow Poisson distribution if it assumes only non-negative values and its probability mass function is given by P of x is equal to x is equal to e to the power of minus lambda, lambda to the power of x divided by x factorial, where x is equal to 0 to infinity and where lambda is greater than 0. So here lambda denotes the mean of the distribution. Actually, Poisson distribution is a limiting form of binomial distribution. So if the number of trials is indefinitely large, then we follow Poisson distribution instead of binomial distribution. And here the small p denotes the constant probability of success in each trial, and it is very small. And lambda, which denotes the mean, is going to be equal to np, and it is also finite. Now let us see a sum in Poisson distribution. 6 coins are tossed 6,400 times. Using the Poisson distribution, what is the approximate probability of getting 6 heads 10 times? So the probability of getting 6 heads in one toss of 6 coins is going to be p equal to 1 by 2 to the power of 6, where p denotes the probability of success. And as I said, a lambda, which denotes the mean, is going to be NP. So which is going to be N here denotes 6,400 into P is going to be 1 by 2 to the power of 6. Therefore, the value of lambda is 100. So now we got the value of lambda. So we can apply it in Poisson distribution formula. So as a result, we will be getting an answer as 1.025 into 10 to the power of minus 30. Let us see another sum in Poisson distribution. If x is a random variable such that 3p x is equal to 4 is equal to p of x is equal to 2 by 2 plus p of x is equal to 0, find the mean and also find p probability of x which is less than or equal to 2. So they have given the relation that 3p x is equal to 4 is equal to p of x is equal to 2 by 2 plus p of x is equal to 0. And we know the formula for Poisson distribution to be e to the power of minus lambda, lambda to the power of r divided by r factorial. So when we are going to apply the value of x in the formula, we will be getting an equation as lambda to the power of 4 minus 2 lambda square minus 4 equal to 0. So by simplifying the equation, we will be getting the value of lambda to be 2. So therefore, the mean of the Poisson distribution is equal to 2, as I said before, lambda denotes the mean of the distribution. Also, they have asked us to find that probability of x is less than or equal to 2. So to find the probability of x less than or equal to 2 is that we can find probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 by applying the value of lambda and also by applying the value of small x in the value of the formula of Poisson distribution, we will be getting an answer as 0.54. Next, we are going to see about geometric distribution. A random variable x is said to have a geometric distribution if it assumes only non-negative values and its probability mass function is given by p of x is equal to x is equal to q to the power of x minus 1 into p, where x varies from 1 to infinity. You have to note that in both binomial and Poisson distribution, x varies from 0 and it goes to n or it goes to infinity. But whereas in the case of geometric distribution, x starts from 1 and does not start from 0. Right? Now let us go to a sum. Suppose that a trainee soldier shoots a target an independent fashion. If the probability that the target is shot on any one shot is 0.8, what is the probability that the target would be hit on sixth attempt? So here they have given the value for P to be 0.8 because the probability of the success is going to be P, and therefore the relation between P and Q is that Q is equal to 1 minus P. So from that we can find the value of Q to be 0. So since we found out the value of P and Q, they have asked that what is the probability that the target would be hit on the sixth attempt, that is P of x is equal to 6. So applying these values, we will be getting an answer as 0.00026. Next, we can see another sum. A die is cast until 6 appears, which is the probability that it must cast more than 5 times. So the probability of getting 6 is going to be 1 by 6, which denotes P. Therefore, Q is going to be 1 minus 1 by 6. They have asked it probability that it must cast more than 5 times. So since can be got either in first, second, or it can goes on any other throws. So we cannot find more than 5 times. So instead of finding P of x greater than or can find it as 1 minus p of x less than 6. So by applying the geometric formula, we will arrive at the answer as 0.4019. Now we are going to see about the famous memoryless property of geometric distribution. If x has a geometric distribution, then for any two positive integers s and t, probability of x greater than s plus t by x greater than s is going to be equal to probability of x greater than t. So to solve this geometric property of geometric distribution, we are going to use the conditional probability formula. So it is going to be that probability of x greater than s plus t by x greater than s going to be equal to probability of x greater than s plus t in intersection x greater than s by probability of x greater than s. So this is going to be equal to probability of x greater than s plus t by probability of x greater than s. So by simplifying this, we will be able to satisfy the memoryless property of geometric distribution. Next, we are going to see about uniform or rectangular distribution. So this is a continuous case. A continuous random variable x is said to have a uniform distribution over an interval a comma b if its probability density function is given by f of x is equal to 1 by b minus a whenever x is greater than a and less than b and 0 otherwise. Now let us see a sum based on uniform distribution. If x is uniformly distributed with mean 1 and variance 4 by 3, find p of x less than 0. So since they have given the values of mean and variance, let us apply the formula for mean and variance. So the formula for mean E of x is going to be equal to b plus a by 2, and for variance it is going to be b minus a the whole square by 12. So by applying b plus a by 2 equal to 1 and by applying b minus a the whole square by 12 equal to 4 by 3, we will be getting the values as a plus b equal to 2 and b minus a the whole square equal to 16. So by equating this, we will be getting the value of a to be minus 1 and b to be equal to 3. So from these intervals, we can determine that f of x is going to be equal to 1 by 4, where x varies from -1 to 3. So they have asked us to find the probability of x less than 0. So the upper limit is going to be 0 and the lower limit as it is given, it is going to be -1. So -1 to 0, 1 by 4 dx is going to give us the value as 1 by 4. Exponential distribution. A continuous random variable x assuming non-negative values is said to have an exponential distribution with parameters theta greater than 0 if its probability density function is given by of x is equal to lambda e to the power of minus lambda x greater than 0 and 0 otherwise. Find the moment generating function of exponential distribution and find its mean and variance. So we know that the formula for exponential distribution is going to be lambda e to the power of minus lambda x, and moment generating function f is going to be equal to 0 to infinity e to the power of dx f of x dx, that is 0 to infinity lambda into e to the power of minus lambda x into e to the power of dx dx. So by applying the values, we will be getting the relation as it the moment generating function of exponential distribution is going to be lambda divided by lambda minus t. And then they have asked us to find the mean and variance. So for mean, mu1 dash is going to be the differentiation of moment generating function with respect to t, where t is equal to 0. So since we know that the moment generating function is lambda divided by lambda minus t, we will be getting the means value to be 1 by lambda, and mu2 dash is going to be again the differentiation of mu1 dash, so we will be getting 2 by lambda square, and variance is going to be mu2 dash minus mu1 dash the whole square. Therefore the value for variance is going to be 1 by lambda square. And memoryless property is also very important in the case of exponential distribution. So if x is exponentially distributed with parameters lambda, then for any two positive integers s and t, probability of x greater than x plus s plus t by x greater than s is going to be equal to probability of x greater than t. So here also we are going to use the same condition probability concept. Probability of x greater than s plus t by s greater than s is going to be equal to probability of greater than s plus t intersection x greater than s divided by probability of s greater than s. So this is going to be equal to probability of x greater than plus t divided by probability of x greater than s. So which is nothing but it is equal to e to the power of minus lambda s plus t divided by e to the power of minus lambda s. So by equating it, we will be getting the value of e to the power of minus lambda t, which is nothing but probability of x greater than t. Let us see a sum in exponential distribution. A component has an exponential time to failure distribution with mean of 10,000 hours. The component has already been in operation for its mean life. So what is the probability that it will fail by 15,000 hours? So let us know time to failure of the component. Then x has the exponential distribution with mean of 1,000 hours. So since the formula for mean is going to be 1 by lambda. 1 by lambda is equal to 10,000. Therefore, lambda is going to be equal to 1 by 10,000. Therefore, the probability density of x is f of x is going to be equal to 1 by 10,000 into e to the power of x by 10,000, where x is greater than or equal to 0. And they have asked that the probability that the component will fail by 15,000 hours, given it has already been in operation for its mean life, is nothing. They have asked us to find that probability of x less than 15,000 divided by probability of x greater than 10,000. Okay, we can rewrite this as probability of x is greater than 10,000 and it is less than 15,000 divided by probability of greater than 10,000. So by applying the exponential distribution formula, we will be arriving at the result as 0.3936. Next, we are going to see about normal distribution. A random variable x is said to have a normal distribution with parameters mu, that is mean, and sigma square, that is variance, if its probability density function is given by the probability law. F of x is equal to 1 divided by sigma into root of 2 pi into e to the power of minus 1 by 2 x minus mu by sigma the whole square, where varies from minus infinity to infinity, mu varies from minus infinity to infinity, and sigma is greater than 0. We have note that X is following a normal distribution, mean mu variance sigma square, which are the parameters, and it is denoted as n mu sigma square. Let us see a sum for normal distribution. Let X be a normal variate with mean 30 and standard deviation 5. Find the following, that is, we have to find the value for probability of X greater than or equal to 26 and less than or equal to 40. So here they have given the value for mean to be 30 and the value for standard deviation to be 5. So by applying the standard normal distribution formula, we can find the probability of X greater than 26 and less than or equal to 40 is going to be equal to 0.7653. Thank you, students. Let us join again in another interesting session. Thank you.